Okay, the following is a video over 10.1 for notes, and we're talking about circles and circumferences and properties of circles. So we've been kind of talking about a circle for a while. The first thing I want to talk about are formulas for the circles. The first one I want to talk about is circumference, and that is the diameter times pi. Now remember, circumference, this is like the perimeter of a circle. Okay, and these are kind of things that I think we come into school with prior knowledge for. And then the diameter, the d is diameter. Okay, and we'll talk all about that. And then we could also express this as the circumference is equal to 2 times the radius times pi. So these are just the same way of writing the same thing. Okay, so then this leads us to say that the diameter and 2 times r are equivalent statements, so we can say that the diameter is equal to 2 times the radius. So if you multiply the radius by 2, you get the diameter. If you divide the diameter by 2, then you get the radius. So let's take a look at numbers 1 through 4, and we're going to look at this circle here. And so we want to first name the circle. It's already kind of named for us. We use a circle with a point in the middle to tell that we're talking about a circle, and then we use the center of the circle, which is point P. So that's how we name the circle. And it says name a radius. Well, I've got a few. Now, a radius is the distance from the center of the circle to the outside, and so I've got a few of them. In this picture, I've got segment PC is a radius. I've got segment PA is a radius, and I've got segment PB is a radius. So notice that in each of these segments, I include point P. Okay, then it says name a chord. Well, a chord is a segment inside the circle that does not go through the center. So if I were to name a chord in this situation, it would be chord DE. Okay, that segment. Okay. And then it says name a diameter. A diameter is a segment that goes from one end of the circle to the other, and it goes through the center. So I would call this segment AB. Okay? So just kind of naming things within the circle. Okay, these are kind of things that we should be able to do. In this next one, it says name a radius not drawn as part of the diameter. So the diameter is from A to B. And so the segment that's a radius that's not a part of that would be segment PC. Okay, it would be that distance from P to C. Suppose the diameter of the circle is 16 centimeters. Find the radius. So let's say that the diameter, this whole length here, is, let me redo that. The distance from A to B is 16 centimeters. Okay, so it wants to know find the radius. Well, I know that the diameter is equal to 16. I also know that the diameter is equal to 2 times the radius. So I could plug in 16 for diameter, and I could solve for my radius, and just divide that diameter by 2, and I get a radius of 8 centimeters. Okay, and that's for number 6. Okay, it says, suppose that PC is 11 inches. Okay, so that radius here is 11 inches. Okay, now I know that this is a radius and it's congruent to this segment and congruent to that segment. And so if this is 11 inches, then this has to be 11 inches and this has to be 11 inches. Okay, so if I add 11 and 11, I find that AB is equal to 22 inches. Okay, finding the total length. All right, so that's problems 1 through 7. Just naming things and being able to determine certain lengths of a circle. Okay, now we get problems 8 and 9, which are a little bit tricky. Okay, now it says here that the diameters of circle F and circle G are 5 and 6 units respectively. So I know that if it says circle F and then it says 5 here, that I know that circle F, this length from here to here is 5. Okay, and then if it tells me that circle G is 6 units. Okay, so what I can do here is I can say that this length from B to G is 6. Okay, And I was able to do that because it tells me the center of those circles. In this circle here, it's kind of hard to determine whether F or B is the center point, but because they name it circle F, I know that F is the center. Okay, and then it asks us to find the length of BF. Well, if I know that this whole length is 6, and this length here is 5, then 5 plus what number is going to give me 6? So you could call this length x, all right? This is length x, so I would maybe set up an equation, 5 plus x is equal to 6, subtract by 5 on both sides, and so I end up getting that x is equal to 1. So I could say that segment BF has a length of 1 unit, okay? And then it wants me to find segment AB. So what I want to do, I know that I have a segment, that the length from F to A is a length of 5, because F to this point is 5, and I know that FA is a radius of that. And I know that this length here between B and F is 1. So let me call that 1. And so what I know, I'll call this length y here. I'll say that y plus 1 is equal to 5. Okay, so I can set up an equation. I can subtract 1 from both sides, and I end up getting that y is equal to 4 units. Okay, so I know that AB, that segment, is equal to 4 units. Okay. All right, let's take a look at numbers 10 through 13. It says, find the diameter and radius of a circle with the given circumference rounded to the nearest hundredth. So when it says hundredth, that is 2 decimal places. Okay, decimal places. All right. So what I want to do, I know this. I know that they want me to find the diameter and the radius. And I need a couple of those formulas. So I'll need that my circumference is equal to the diameter times pi. Okay, remember pi is a number. All right, it's 3.14159. And then I also know, because we're trying to find the radius, I know that the diameter is equal to 2 times the radius. So I can actually solve for the radius here and divide both sides by 2. And then I get that the radius is equal to the diameter divided by 2. Okay, so I'm going to use these formulas to help me do this. So in number 10, it tells me that my circumference is 36 meters. So I'm going to take 36 meters and set that equal to the diameter times pi. Okay, now pi is a number, so I'm going to divide by that number pi. Okay, so I get that my diameter is equal to 36 divided by pi. Let's plug that into our calculator. And what we'd want to do is we want to take 36 and divide that by pi. And I get 11.45, so 2 decimal places, so that's 11.46. So my diameter here is equal to 11.46, and this is meters. Okay, now what I want to do is it wants me to find the radius. So if I take this number and I divide it by 2, so if I take the radius is equal to 11.46 and divide that by 2, let's use our calculator just so I make sure I get this right and I don't screw anything up. I'm going to take 11.46 and divide that by 2, and that's going to give me 5.73. So my radius is equal to 5.73 meters. Okay, so those are the answers that I'm looking for. So I'll do number 10 and then number 12. I'll let you guys work on 11 and 13. Number 12, it tells me my circumference is 81.3, so I'm going to take 81.3 and set that equal to diameter times pi. And if I'm solving for my diameter, I'm going to divide both sides by pi. And so I get that my diameter is equal to 81.3 divided by pi. So let's go to our calculator, and we're going to take 81.3, and we're going to divide that by pi. And we get 25.87. So I'm going to round that to 25.88. Is it 25, right? Okay, so 25.88. So diameter is equal to 25.88, and that's in centimeters. Okay, so if I wanted to find my radius, I would take that number 25.88 and divide that by 2. So 25.88 and divide that by 2. End up getting 12.94. So my radius is equal to 12.9. Wait, what was it? 12.94. Okay. All right. So, guys, you're just using a formula here. I think that these are things that we are able to do. I'll let you work on 11 through 13 for time purposes. But then let's take a look at 14 and 15. Now, these are a little bit tricky. Now, what you have here is you end up having within a circle, because of how it's set up, because all of these points are equidistant from the center, it wants us to use the lengths of this square to find the circumference of this. So what I know about this first example is that I have a square, okay? I know that this is a right angle. Because it's a square, I know that this is a 45-degree angle and a 45-degree angle. And I know that this is 3 centimeters. So then my diameter, this length here, has to be 3 times the square root of 2 centimeters, based on what we had just learned. Now, you could find this number by using the Pythagorean theorem, but we can use a special right triangle to do that. So the diameter is equal to that. Now it wants me to find the circumference. So I'm going to take my circumference, which is 3 times the square root of 2, and multiply it by pi. Okay, and this is the exact circumference. Okay, even though we don't really have an actual number, this is the product of 3 numbers. Now these 2 numbers, the square root of 2 and the square root of pi, are irrational numbers. They will never repeat, they will never end. And so this is exact. This tells me the exact distance around it. We could put it in a calculator and approximate it, okay? Now, I know that this length is 8 right here in number 15. I know that this length is 15. So what I want to do here is I'm going to label this 15 feet, and I want to solve and find the length from here to here, okay, the hypotenuse of this right triangle. I'm going to call that D. So I'm going to say that 15 squared plus 8 squared is equal to D squared. Okay, using Pythagorean theorem, I can solve for D here, and I could say that D is equal to the square root of 15 squared plus 8 squared, all right, which this ends up giving me the square root of 225 plus 64. So 225 plus 64, 225 plus 64 is going to end up giving me 289. Let's see if we can take the square root of that. So the square root of 289, I don't think we can. Oh, it's 17. Okay. So if we plug that into our calculator, we find out that the diameter is equal to 17 feet. Okay, which is pretty nice. Now for our circumference, we would take that number 17 and multiply it by pi. Okay, and that would be in feet. This would be in centimeters. Okay, so that is my exact area, or exact circumference, because that is in terms of pi. Okay, pi is an exact value. 3.14 is an approximation. So I hope that this helps. Please use this and these examples to work on the homework, and come to class ready to work on those. Thank you for your time.